Our next speaker is James Lee from Google, who will show us the vision of Google in that connected worker field.
Great. Thanks a lot. Good morning, everyone. Let me just get my presentation up here. Let's see.
Hang on.
Oh,
Hang on. Here we go.
you can do it faster, I think. No surprise, I'm not a Windows expert, so it's just
Obviously.
institutional bias.
Here we go. So.
Oh, no, present. Oh, how do I?
Present probably.
Yeah, present. Disappearing mouse.
Disappearing mouse.
There we go. Excellent.
The question is, will it appear there?
Oh,
No, for sure not. But we can make it happen.
you really are IT support. It's great.
Better.
All right, thank you. Great. So, what did you guys think of Google Glass? Did you get a try it to register? Yeah? It takes a little getting used to, I'll admit. And I think that's one of the reasons why we're here. It's why we're so focused on the user experience. It's also one of the reasons why we don't sell Glass directly to customers. We actually insist that they use a solution provider like Upskill and a partner like Nagarro to really implement it correctly. Because we think that initial end user experience is absolutely critical to success. Because you may all see the benefits to it and the business value. We'll talk about all that. But at the end of the day, if your employees that are using it find no value or find it inconvenient, after all, it's sitting on your face, then you're not going to have a good experience and you're not going to see that business value, right? So let's get into that a little bit. So today I'm here to talk about, along the lines of the connected worker, where Glass fits into that whole ecosystem. And I think Umang did a fantastic job of kind of laying the foundation, because these sort of digitization efforts, we were actually talking about this last night, without digitizing your data and actually get it ready for devices, whether it's mobile or Glass, you're not going to be able to leverage that sort of real-time vast body of data you may have in your back-end manufacturing execution systems, ERP, et cetera. So a little bit of advertising for Google here, not that we need it, but you know, I'm required to do this. Not really, but I'll put this in here anyways. But I think over the years, I've been at Google for about 7 years, and sorry, I'm fighting a little bit of a cold, so apologies. We've come to become a symbol of innovation. Certainly from where we started to where we are now, the rate of growth and the number of users, if you look across some of our products, across our product base, we have over 1 billion users for 8 of our products and 2 billion for the main service, which is search. So that really started from a small number and grew very rapidly, and we think that the way in which we approach things enables us to do that. Part of it is the way in which we allocate resources. I talk about this quite a bit, but early on, the founders, Larry and Sergey, said, okay, so for the things that we're working on that are very successful, back in those days it was search, we're going to allocate 70% of our human capital, of our money, of our time, to make sure that those keep going and keep growing and so forth. As you know, with search, it's not very sticky. You can switch at any time. It's a matter of typing it in a different URL. So if it's not useful, you're not going to use it, right? So that's what that investment goes into. 20% is for very promising bets. You know, when I started, Android was a very promising bet. I think there were 100,000 people activating every day, which is, of course, a tiny number nowadays. And so that 20% really kind of represents a double down on, you know, sort of very growing new technologies. The 10% is really focused on the moonshots, the 10x, as we like to say, the projects that can improve something by 10x. We often say it's sometimes easier to improve things by 10x than 10%. So along that lines, the 10% is around allocating resources to these moonshot projects. So a couple of examples. You may have heard about the self-driving cars. We just launched that in Phoenix recently. Fully, there's no one in the driver's seat. And a couple of other things, I'll go through these quickly. Project Loon, which is helium balloons that deliver broadband internet. Recently, we sent a couple over to Puerto Rico, delivering LTE service to 100,000 users. We've done that in Peru during the last earthquake and a couple of other places. Project Iris is being able to read your glucose levels through a contact lens. You've got Project Tango, which is simply a phone that sort of spatially aware and enables some augmented reality type capabilities. And down the line here, drones for delivering burritos, for instance, or a faster way to kind of create mesh networks. Makani is actually an interesting use of kites to generate electricity. And then finally, glass, probably one of the early bets around this idea that a wearable on your head, and this was back in 2011, 2012, could really be the killer device, killer app, and all that. But sometimes these bets don't always work, right? Glass was fundamentally, I think, challenged by product market fit, right? We focused 100% on consumer. We focused on, creating this very kind of tailored experience for consumers. You enter in your, Google account and everything's wonderful. But there was a social acceptance issue. You may have heard the term glass holes, right? And so we kind of backed away from that. The Explorer program was ended in early 2015. But the interesting thing was that we found about 25% of the people that bought these devices were actually folks like you. Big companies that saw a clear value. They didn't care what it looked like. All they wanted was the ability to have a display above the eye that could essentially allow workers to work hands-free. That's as simple as it is. And you'll see that theme kind of go through my whole presentation and others as well. So there was real value that was able to be extracted out of glass on the business side of things. So in 2015, when I joined the glass team, my charter was to essentially find customers, enterprises that could actually deploy glass successfully. And if you look at sort of the trends in the last 40 years of enterprise computing, the desktop, obviously, in the 80s, that took off with the PC and the Mac and all that. And it revolutionized information workers, their ability to access, ancient mainframe computers and so forth. You look at mobile in the past 10 years and how it's taken that PC and that computing and brought it down to people in a retail store, people who are field technicians, people anywhere, outside of the office, right? Were enabled by this device. So, to, I guess, sort of put it in that context with wearables in general, but glass as a leading candidate, of wearable devices to access the hands-on worker. In the US, that adds up to about 14 million workers. Globally, it's probably 4 or 5x that easily, if not more. And so reaching those users we view as sort of net new users to this world of information technology, essentially. And so this is the area we're going after, straight, plain and simple. No more consumers, 100% enterprise for now. So a little bit on definition. I'm sure you've all heard of virtual reality and augmented reality. We prefer to use the term assisted reality, thanks to the folks at Upskill who really sort of inspired this term. Where the idea is augmented reality presumes that the device you're wearing has some sort of spatial awareness of the world, right? When I turn around, it's able to do a digital overlay. You've seen some of the demos where if I'm staring at a table with a device, I can see like a dancing elephant, right? Something like that. So that's very complex, and there are some really cool demos out there, but we feel that in the production environment, in the rigors of your businesses, that this doesn't really work. Not yet, anyways. But we feel that using assisted reality, which is essentially a dashboard that sits above your eye in the demo that you guys saw, that essentially is a dashboard to whatever information that is relevant to your task at hand. If I'm assembling an engine, if I'm maintaining a wind turbine, etc. So assisted reality is really this notion, if you see in that upper right-hand corner, that black square, a dashboard that gives you that data without having to do all the fanciness of augmented reality. This works today, and we've seen real production results with that. The good news is there's definitely a spectrum that if you start the journey with assisted reality, you can kind of incrementally move to augmented reality. The digitization of your information, for instance, is a critical first step. Getting all of your CAD drawings and your videos and your pictures and all that sort of stuff that are associated with assembly tasks or standard operating procedures, that sort of thing, will enable glass and other devices down the road. So if you remember back in, let me show of hands, does anyone remember back in July, a couple months ago, the announcement of Glass Enterprise Edition? A few? Okay, we didn't do enough, I think, PR maybe. But we launched this officially, publicly, on July 18th, and this is actually fantastic relief for me personally because I'd been working for about a year and a half completely privately with many, many customers prohibiting them from saying a single thing about what they're working on. It was a little bit like Fight Club. In fact, the last Nagarro event, which I think was in June, right before our public launch, it was killing me because I couldn't talk about it, right? So I'm glad to be here to kind of talk about this. And so it looks very similar to the first one. The difference you may have noticed when you were trying it out up front was, it has a hinge, for instance, which sounds very basic, but that allows a great degree of modularity. You can attach things like safety frames, corrective lenses. There's a safety shield here for manufacturing scenarios. But essentially, the basics are a camera that's line of sight, so that when I look at something, my camera's looking at the same thing, right? The hands-free, again, that's a theme throughout this whole thing. I have a computer on my head. Instead of having to hold a mobile device, I just have it there, and I can do all the things I need to do with my two hands. As humans, that's kind of important. The last thing is two-way communication, this idea of see what I see. When I project someone 5,000 miles or 500 miles away, can see what I'm seeing on their laptop, as you'll see in the demo, and be able to take a snapshot, mark it up, send it back to the worker. It's critical in areas of things like maintenance and training and so forth, and we'll talk about those use cases. I usually don't show a spec slide, but we're public, and people have always asked about this, so may not mean a lot to you, but there are fundamental improvements from the first generation device. We've moved from an ARM-based chip to an Intel-based chip, which improves video encoding and decoding. We've greatly increased the battery size by about 40%. We've made the device water and dust resistant. We've ruggedized it a bit in that regard. And the modularity, as I pointed out. Key thing that I think is really interesting, though, is we've totally removed all Google services from this device. So there's no Gmail for you to enter. There's no Hangouts. There's no things like that. The whole idea is that we want you to work with our solution providers who kind of build this device into a purpose-built tool. So that's really the idea. So just again, a little bit more context here. So if you look back, 50, 60 years ago, this was kind of what a typical back office looked like with typewriters and phones and so forth. Today, it's very different, right? You've got computers, right? That's everything it is. Everyone's got on average, 3 screens, I hear, right? So it's very different. If you look at the manufacturing floor, for example, again, you see an assembly line and people assembling parts, putting in engines and so forth. It doesn't really look that different today. Certainly, they're making much more complex items at a much larger scale and using very complicated tools. But at the end of the day, they're still doing a lot of hand assembly. One aerospace manufacturer told me that even today, 80% of the plane is completely built by hand. Only about 20% is automated. So your industry may vary, but on average, we still see that quite high amount of manual labor required to build the things that we use today. So the idea is, with wearables, we think that it's one of the last areas where there's a net new opportunity to add workers into sort of this real-time world of information and access to enable them to do their jobs better. Simple as that. Okay, so a little bit more detail on what Glass can do for you. The idea, again, recurring theme here, is stay hands-on, right? And how do we do that? It could be, again, I'm getting real-time instructions from a manufacturing execution system. In the case of Boeing, where you get these wire harness instructions. These airplanes have 150 miles of wire in them. Being able to dynamically get real-time instructions, which may be highly variable from task to task, specific to the user, is very incredibly efficient compared to, say, either going off a piece of paper, which surprisingly is a common recurring solution, or using a PC where the worker has to look at the PC, turn back to the task. They're like, oh, did I see that right? They look back and forth. That right there adds up an incredible amount of time and errors, right? So in the case of building an airplane, that's not a good thing. So you want to reduce errors as much as possible. And then instant expertise, this idea of in the connected world and the global economy that we have, oftentimes experts are thousands of miles away and often have to be flown in, whether it's for airplane maintenance or some other complex device. You're often, out $20,000 just to send someone to go on site to actually do any of the repairs, right? So being able to have someone from their desktop join in and see what the worker is seeing and say, no, you have to remove that module, undo that screw, add that bolt, et cetera, right? So very specific instructions that while you can kind of do it with a mobile phone, not really as effective, right? So we've seen great uptake in the instant expertise as a really key driver of business value with glass. So to summarize it, as far as where glass can be used, where we see the most value, because everyone's got hundreds of different ideas. In the last few years, our experience has really kind of been distilled down to this. Anytime you need to move something, think supply chain, just-in-time inventory, warehouse picking, logistics, et cetera. We think there's a lot of value in using glass, right? Anytime you have to make something that's highly complex, highly variable, whether discrete manufacturing or process manufacturing, we think that there's also a lot of value for workers to deal with that variability, right? Anytime you need to inspect or repair something, they're kind of two sides of the same coin. Inspection typically requires going down standard operating procedures, work instructions, and so forth. Glass is great for first documenting that, making sure that there's high compliance, and also for documenting any kind of out-of-compliance errors and so forth, so that you can then bring it back into your back-end systems for analysis. And then repair, again, a simple, similar to inspect, is that there's standard procedures you go through, but the added feature that is often used in repair is the see what I see, as I talked about. Being able to turn on the camera on your glass, look at what you're looking at, stream that video back to an expert, and have them give you, as the worker, guidance and instructions on how to fix the problem. So that's simply it. So move, make, inspect, repair. That's where we think the targets are. So think about it in that context. To give you a sense here of the features we've built into glass that enable this, so task completion and verification, like I talked about. Upskill does a fantastic job of taking data from your manufacturing SAP system, for instance, taking those tasks, determining who the user is when they've authenticated into the glass, sending them only the information they need to do their job specific to them, and then when they complete it, send that completion data, whether it's documenting errors or just documenting the completion time, back into that ERP system. So you have a complete loop of how everything happened versus just, here's the instructions, figure it out, right? Instant communication, again, this idea of two-way video communication, again, not a new technology, but using glass as a different device gives the video communication a whole different flavor, right? Because you're not seeing the person, you're seeing what they're seeing. And it doesn't just have to be from glass user to person on a laptop. It could be glassware to another glassware, or a glassware to multiple glasswares, right? So there's all kinds of permutations you can think of. The real-time training is really critical. It cuts across all those use cases that I talked about, the move, make, inspect, repair, because workers always have to be trained. There's a huge demographic shift happening in the next 5 years, right? Of up to a third of all workers retiring, right? In the next 5 years, baby boomers and so forth. So how do you transfer that vast amount of knowledge to the new millennials who famously, of course, have super short attention span? To give you an example, AGCO is a large manufacturer of agricultural equipment, tractors and so forth, both in Germany and US and globally, actually. They've reduced their training costs and time by 50%. For new workers, when they start training them, it's typically a 2-week cycle. Now it's 1-week cycle, because what they do is they train them for 1 week, then they give them glass on the second week, where they're still learning, but they're learning while they're manufacturing the tractor engines and so forth. So while their actual productivity might be a little bit less than a regular, full-time employee that's been working for many years, they're still being productive. They're still actually contributing to that productivity, right? So they're sort of training and working at the same time. Notifications are critical in the cases of the maintenance use case. Being able to get notifications that, for instance, a reagent is running low in the case of process manufacturing, or that particular parts for just-in-time manufacturing are running low and they need to be replenished. So that notifications is really significant. And all of these together, if you think about it, when I'm wearing glass, when any worker is wearing glass, they're a giant sensor. There's eyes, there's hearing, vision, there's all kinds of other signals that can be captured by glass. That just becomes a huge big data sort of BI opportunity to sort of see trends in your processes, to see what areas are slowing down and what areas are doing great, which groups are doing great, which groups maybe need a little bit more guidance, right? So there's a huge kind of big data opportunity, and when my colleague Sabs comes up to talk about the cloud opportunity, he'll talk about some of those things like machine learning, computer vision, so forth. Oh, and an example of some of the customers and the industries that we're in, right? So manufacturing, I've been talking about that a lot. Logistics, healthcare, and field services are really some of the key industries. Also retail is actually starting to really pop up as a promising area. Some examples of customers who have tested glass, and this was actually before we even publicly announced. We did about a year and a half of pilots and work with a wide range of customers, about 50 customers, to sort of validate the results that we expected with glass. And the great news is that they were largely highly validated. And the way in which we got there kind of came up with this formula. It's nothing magical. It's probably pretty obvious for many of you. But the idea is, you all have some sort of vision that, maybe of a manufacturing process that is kind of removed a lot of the errors that you have today. And you've come up with some sort of innovation to apply to it. So these are the first two steps. Having that vision of what you want to improve. I want to reduce error rates. I want to increase productivity. I want to reduce training costs, whatever it may be. And then figuring out what is the way in which I could actually tackle that. So I think I view innovation as sort of applied vision, right? Using technology like glass to tackle that. The third thing is business value, is that you have to have a baseline to compare. You have to know how long something takes to do, or you have to know what your error rate is, or you have to know what your training costs are before you can actually improve it. That's pretty obvious. So we always insist upon that. That's a best practice. It's obvious. The last two, I think, are very specific to glass because we've taken this ecosystem approach. We're not going it alone like we did the first time around. Our partners are absolutely critical here, like the folks at Nagarro and Upskill. And so that trusted ecosystem is really what enables this device to work properly, and that's really the key. The last piece is realistic scope. Earlier I talked about augmented reality and kind of that futuristic vision of what it can do. And so people kind of have that in their mind when they kind of go forward and do these implementations. And I would urge you to really kind of listen to what the partners have to say about what's doable, what you can start with. You can always start and kind of incrementally improve, right? And incrementally change. So I think that's really the key here. And that's what I think will get you to successful deployment. So the business value that I talked about earlier, these are some numbers, again, thanks to our friends at Upskill, and thanks to our public launch that we can now share with you. So really, really significant savings, and you may think this is absolutely crazy. There's no way this is true. These are numbers that are tied to specific processes within these organizations. So in the case of Boeing, I talked about the wire harness assembly in their jets, in their commercial jets and military aircraft. This reflects a 30% reduction in errors with regard to actually putting in the wire harness, because rework on a jet plane with these wires, I've gotten stats anywhere from 100,000 to more per wire to fix a connection as far as testing and all that. And so anything you can do to avoid that is obviously significant. GE Healthcare, again, dramatic increase in productivity. There's a fantastic video on the Upskill YouTube channel that shows a worker doing picking in a warehouse and showing the difference between how they did it with a PC and then how they do it with glass. Same thing goes with Bell Helicopter. They do this with wire harness assemblies as well. And so a significant reduction in errors and increase in productivity. And then healthcare is one use case I haven't talked about, but it's one that's quite growing in the US anyways. Doctors wearing glass during their patient interactions. And when they're wearing glass, there's what we call a scribe in a call center who's actually seeing the entire patient interaction, and it's with the patient's consent, of course. And the e-scribe is taking notes completely for the doctor, so the doctor doesn't have to worry about taking notes. And so on average, they can see 25% more patients or play 25% more golf, either way. And so significant improvements there on the healthcare side. I don't talk about it too much out here in Europe, but in the US, it's a growing use case. So to kind of wrap it up, to kind of wrap it up, again, we talked about the desktop and what's that done. We all know that. talked about the mobile revolution, but we really think that wearables ultimately has that opportunity. It's still super early, and things can change very rapidly, and we're still working on new versions that we think can improve upon what we've built today. But we think at the end of the day that there's a huge opportunity for wearables, and we think there's a huge kind of opportunity from a business value standpoint, not just for the sake of technology because it's cool. So I'd urge you to look at this from a standpoint of where can it improve a particular process in my business, and where is it realistic to use, right? With that sort of realistic scope. And then, again, I would urge you to talk to Jay and talk to the Nagarro folks about what they can do to kind of get that ready for you, because certainly that digitization strategy needs to be in place for this to work. So, thank you.